Alright, and welcome to the video for 5.1 where Mr. Hong is out of town, so we're going to be watching a video. So, today we're going to be talking about how we're going to be graphing quadratics, and this is actually a very easy unit because we link it very closely to a previous unit, Unit 2, where we talked about how we can find the attributes of a absolute value by using the compass method and by finding the intercepts, the vertex, the axis of symmetry. We're doing the exact same thing, but only to a quadratic now. So it's not going to be to a absolute value anymore. It's going to be to different graph. So how can we identify attributes of quadratic functions written in standard form and in vertex form? So first we have to label, or we have to understand, what is standard form and vertex form. And I'm going to just show you real quick just because of educational purposes, but standard form looks like this. X squared plus bx plus c. And the vertex form is going to look like a times x minus h squared plus k, which is labeled actually here. And just know that very similar to the which is labeled here, sorry. Just notice that the h and the k is still very similar to the same thing that we learned from last unit, or 2 units ago, where we said that h and k, which is here as well, is my vertex. So the same rule applies here as well. So this is going to be h comma k. The axis of symmetry, the same thing as well. X is going to equal h. So these points are the x-intercepts, which are right here. So I'm just going to write here that x is equal to -1 and 3. And I'm going to also say the y-intercept here. This is 1, 2, 3. Y equals 3. So this little box right here is actually very important, where it says the x-intercepts of a parabola is also known as roots and zeros. So x-intercepts is the same as solutions, which is the same as roots, which is the same as zeros, which is this, and these two things are the same. These two things are the same. So all 4 of these words actually mean the same thing. So all of these is x equals -1 and x equals 3. Standard form we're going to be talking about a little bit later in this unit, but I just wanted to show you already that you can write quadratics 2 different ways. So why am I talking about the 2 different types of versions? The reason why is because we can say that this equation right here and this equation are actually the same. It's pretty much saying okay, Mr. Hong, if you didn't know, my full name is Joseph Hong, but also my full name is this in Korean. I wrote that really ugly. I'll write it better. So if you're taking Korean, you can see okay, you could read this yourself. You can take that to Dr. Kim. She'll read it for you. I won't say it. But these 2 things definitely mean the same thing. So when I talk about x plus 2, so that's getting squared, minus 5, and x squared plus 4x minus 1, these 2 are the same thing. And I can just show you on Desmos, so let's come right back. Okay, so if I type in x plus 2 squared minus 5, and I do x squared plus 4x minus 1, let's take a look. Gotta find my graphs first. So we can see that, okay, my blue graph is graphed. So if I hide the blue graph, it becomes a red graph. So these two graphs are exactly the same. So here comes a like example. So example one. So using prior knowledge, analyze the key attributes of this function. So even if I type this inside Desmos, it's not going to tell me too much in Desmos. But I do want to say that this is still a compass where we do the Desmos, or our domain and range, where we use the compass. So I taught my class north, south, east, and west. And the first step that we have to do is identify what my arrowheads right here are facing towards, compass direction wise. So this is going to be northwest, this is going to be northeast. So once again, very similar to what I did 2 units ago, where you see that my arrowheads right here are northwest and northeast. So the one direction I did not have was no south. Therefore, I had to find my own south, which is the lowest point on my graph. So it was y equals 0, because this is 0 units high, which is my vertex right here. So on this graph right here, I need to find where my lowest graph is, which is going to be right here, where this order pair is 3, -1. This is going to come in very handy right here, because this lowest point is actually my vertex, 3, -1. Which I'll just highlight pink for you. Okay, and as you see, like this U shape right here, this is opening upwards. So like if I like drew a picture right here, that's really bad. But like let's say for example, this is like a whale, and like I have teeth right here, and this is Mr. Hong, you know, like going in to save the princess. Whatever. You can see that the mouth is facing upwards. So this is actually facing upwards. Axis of symmetry. Very similar, where you see, okay, I have this 3 right here. So my axis of symmetry is going to be x equals 3. Which is actually, which I'll color in this orangey color. That this right here is my axis of symmetry, which is true because the left side is gonna be the same as the right side if I fold my paper along this line. As this line right here, the axis of symmetry is gonna be my crease of my paper. So this is true. Here we go. Domain and range. So I have both. It's going to be west comma east, right? So this is going to be -infinity to infinity because I have both my west and my east, which is right here. But the problem with my range is that, well, it's going to be south comma, not east, south comma north, but I do not have a south. Therefore, I have to find my own south, which is actually right here. This -1. So -1 comma infinity. So infinity, we're going to use parentheses because we cannot quantify infinity. But with this -1, I need to use a bracket because this is a solid dot. So I'll just color this -infinity. Or -1, sorry. And like this blue, notice north, I have north, which is here. Good. Intercepts, these are talking about all my intercepts. I'll be actually writing just the y-intercept in this space because when we talk about zeros, we'll get to the x-intercepts. So the y-intercept, which I'll color maroon, is going to be right here. This order pair right here is 0, +8. Oh, I wrote that bad. 0, 8. So when I talk about the y-intercept, I don't want to write it as an order pair. I want to write it as y equals 8. You could write it as 0, 8, but it's more widely approved that you write it as a equation. But let's look at the zeros. The zeros, remember, the zeros are the same as the x-intercepts. So that's why I didn't include my x-intercepts in this part right here for intercepts. So my x-intercepts, I have 2 of them. I have 1 and 2. So this order pair right here, this is 2, 0. And this one right here, this is 4, 0. So both of these is true. So I need to write both of them. And the last part, the minimum and maximum. This is actually going to be referring to my vertex. And this is going to be talking about your y value. So in this question, it's actually asking you, which one am I going to be finding? My maximum or my minimum? So you see how like my arrowheads are facing northbound right here? So my maximum is going to be infinity. And that's kind of useless in my opinion because I can't quantify infinity. So that's like just whatever. But the minimum is quantifiable where I could give it a number, which is going to actually be right here in my vertex. So that's why I told you to look at your vertex. So this is actually going to be y equals -1. Here we go. Nice. So very easy. We're using a lot of the skills that we learned in Unit 2 to help us do this problem with a different graph. So it translates very well, and like it ends up getting easier as the year goes on. So I would like for you to try example 2 by yourself. So let me pause the video, or you should pause the video at this time and try it out. I'm gonna give you 5 seconds to try it out yourself before I go over it. And here we go. So I have my vertex, which is right here. So I'm just gonna go this pretty quickly. And it opens downwards because if I draw like my whale, or I guess my shark in this case, because he has sharp teeth, it looks like this. So he's facing downwards, or he's opening downwards. Okay, the axis of symmetry is x equals 1, which I will actually draw this in maroon, which looks like this. You see how it includes my vertex right here? It has to make sense because my vertex is the middle of my graph. And doesn't my axis of symmetry, doesn't it also have to be in the middle of my graph? So it does have to include my vertex, which is right here. Okay, domain and range, we used the compass method, so I did not have north. So I'm going to just write no north. So that's why I had to find... That's why I had to find my north right here. Intercepts, which is going to be... I'll color it as blue, even though my graph is blue. This is right here. But let's look at the zeros. Like, I don't have any x-intercepts, right? My graph is too low. And that's okay. So you're allowed to write NA, which means not applicable, because, well, I don't have any x-intercepts. That's okay. And the last part, maximum minimum. This is definitely going to be the maximum because I can find the maximum, which is quantifiable, which is actually my vertex. So this value, which I found, y equals 4, is from my vertex right here. So in the end, today we learned how to use prior knowledge. So we used Unit 2, information, info, where's my eraser? To identify key attributes of a quadratic. And this is very Algebra 1 because this is actually one of the last few units of Algebra 1. Oop, I wrote 2. But we're going to be expanding and getting more into depth about quadratics. And this is really like the core behind Algebra 2. Because we're going to be learning how to factor, we're going to be more comfortable finding x, and we're going to be more comfortable talking about these key attributes that are required for you to know for you to pass Algebra 2. So, after you watch this video, I would like for you to do the exit ticket. Make sure you did your do now, and I'll see you guys next time. Bye, guys.